Right, I want to look at converting equations between Cartesian and polar. But before we do that, let's look at Desmos for a minute, because I want to show you how to use Desmos to do things with polar coordinates. On Desmos, if you come over here and you type in r equals 3, notice it gives me a circle here with radius 3. Um, the way it knows that you're trying to do something with polar coordinates here is the fact that you gave it an equation that starts with r. So like r equals 3 gives you the circle with radius 3. R equals 2 gives you that. And, um, if you do r equals theta, you get this spiral. And that's kind of interesting. If you think about what that is, if you start at the origin, and you start tracing around that spiral, at each point the radius is equal to the angle. And I think that's a few places where that's kind of easy to see is up here at well, if you look at right here, this is the if you come along the negative x-axis, that's of course the angle pi, and notice it crosses right there at pi. So you can do a lot of interesting things here. If you put in like sine theta, notice what you get. You get a little circle here. If you make r equal cosine theta, you get a circle there. And if you put sine theta plus cosine theta, you get this circle. So it's interesting in that, I mean, it sort of makes sense for polar coordinates. It's really easy to graph circles here. If you start putting in coefficients, like 2, 3, 4, things like that, it'll make the circle larger. What if I put a different coefficient on both of these? Can't really tell what's going on there. Oh wait, yeah, I can. If you look at this, that tells you where the other, like this 2, if I change that to a 3, it changes where the circle intersects the x-axis. If I change this to a 1, it'll make the circle intersect the y-axis at 1. So anyway, we'll get into this a little more later. But what I wanted to do first was just show you can use Desmos to do polar graphs. Now, if I come over here and change the graph settings, you can change the grid. Right now it's on a rectangular grid. You can change it to polar grid. And then that makes, well, it gives you a polar grid instead of a rectangular. All right, so let's go back and look at this. How can we, let's convert some equations to polar. Now this is interesting right here. X equals 5. We know what that is. That's x equals 5, that's just a vertical line. If we want to convert that to polar, what we would do is we'd come up here and we'd find the equation. Well, we take this equation here. We just put, we'd replace the x in it with 5. So you take x equals r cosine theta, replace the x with 5, and then let's solve it out for r. R equals 5 over cosine theta. And that's it. We could leave it like that, or we could write it as r equals 5 secant theta. Either one of those is perfectly good. Now what's this equation? X equals 5 is just a vertical line over at 5. If we go over to Desmos and try to graph this, now a cool thing with Desmos is I could put in x equals 5 here, and even though we've got the polar background, it'll still graph rectangular equations. You put in y equals x squared and you get that. But if I put in x or r equals 5 secant theta, notice it gives me that vertical line there, just like we expected. So let's do a couple more of these. Y equals x minus 1. Now we know what that looks like. Y equals x minus 1 has a y-intercept of -1 and a slope of 1. So it looks like this. Now that's a line, so its equation with rectangular coordinates is simple. Y equals x minus 1. To convert it to polar, what we'll do is we'll replace the x and the y both using this and this. So x, or let's see, y becomes r sine theta equals r cosine theta minus 1. Now, can we solve this for r? I think so. If we, let's move both of the terms with r in it to one side. So we get r sine theta minus r cosine theta equals -1. Factor out the r. And then we get r equals -1 over sine theta minus cosine theta. Now, personally, I don't like that -1 on top, so I'm going to multiply the top and bottom by -1, although this is purely, it's not necessary. But if I multiply the top by -1, I get this. If I multiply the bottom by -1, I get cosine theta minus sine theta. So if I graph that on Desmos, it should give me the little graph we saw over there, just the line. So let's switch over to it. R equals 1 over cosine theta minus sine theta. And sure enough, it gives us the same that we would get by graphing y equals x minus 1. All right, what about this one? Convert x squared plus y squared equals 4 to polar. Honestly, I've left a lot more space here than we need. On this one, well, actually, maybe I will use the space because I want to do this a couple of ways. The easiest way to do this is to come back up here and grab this guy here. X squared plus y squared equals r squared. So I'll replace this with r squared equals 4. And that'll give me r equals, I guess technically it would be plus or minus 2, but we can just pick one of those two to use. R equals 2. Why can I do that? Because remember, when you have an equation where it just says r equals 2, there's no theta in there, so it means r equals 2 and theta is anything. Or theta takes on all values. It's kind of like when you graph the equation y equals 3. You know, that looks like this. Y is 3 and x takes on every value from -infinity to infinity. So anyway, we can do that and it gives us r equals 2. And of course, what is this? This is an equation with, or this is a circle with radius 2. And this is also a circle with radius 2, but just written in polar form. Now, let's say you didn't notice this. Could you do this the same way we did the other problems? Yeah, this is just really more of a stunt to do it this way. The way we just did it down there is by far the better way to do it. But if you wanted to, you could take the x. You could replace the x with r cosine theta squared. Replace the y with r sine theta squared equals 4. And when you square this out, when you factor the r out, or the r squared out, you're left with cosine squared theta plus sine squared theta equals 4. And of course, this thing inside of here is just 1. So this gives you r squared equals 4, or r is 2. So you can do it either way, but definitely, when you're doing these conversions, anytime you see x squared plus y squared, just go ahead and replace it with r squared. All right, let's look at this one. x squared plus y squared equals x. Convert that to polar. All right, x squared plus y squared becomes r squared, and x is r cosine theta. So this is what we get. Let's see, what can we do now? We'd like to solve this for r. Let's put everything on one side. So we get r squared minus r cosine theta equals 0. Factor an r out. So you get r times r minus cosine theta equals 0. So we get r equals 0, and we get r equals cosine theta. Now I'm going to keep this. And what about this over here? R equals 0, that's just the origin by itself. R equals cosine theta is going to be something more interesting. We saw it a minute ago. It's going to be a circle. But do we need to keep that R equals 0 part? I don't think so. Here's why. If I just graph this on Desmos, R equals cosine theta. Notice this includes the origin. It's this circle. It includes the origin. So that means I can throw this part out. I don't need it because it's not that it's not true. It's just that this is included over here. And notice what we got out of this. We got a circle. This right here, if you looked at it, this is a circle as well. If you wanted to find the center and radius, you'd have to do some completing the square and stuff. But anyway, so this gives us a circle. All right, this video is getting a little long, and I've got several more examples. So I think I'm going to cut this off here, and we'll pick up on example 305 in the next video.